And Year 9s, and welcome back to mathematics. In this video I'm going to go through the next section in your learning from home booklet and look at finding a missing angle using trigonometry. Now in this lesson I'm focusing on using trigonometry to find missing angles, and there's two kind of things we want to look at. So we want to understand what a thing called inverse trig is and apply inverse trig to help find missing angles. So those are two things we want to do in this lesson. Okay. To get started, let's do a quick recap of what we just looked at in the last set of videos. If you haven't watched them already, go do so. But in the last video, we were using trigonometry to help us find missing sides. And in particular, we were using trigonometry to help us find missing sides when the missing side was in the denominator of our trig equation. So let's have a go at this question over here, just as a quick recap. So the first step, we had 4 steps that we used when we were trying to find a missing side with trigonometry. Now, if you have the first step was to identify and label and identify. So we want to label our sides and identify what trig ratio we're going to use. So when we identify our sides, when we label our sides, we start off with the hypotenuse. So right angles there, I go across, the hypotenuse is over here. So this trig equation is not going to involve my hypotenuse because I have no value there. So the next side is I go to my angle. So here the angle is 45 degrees in the bottom left. I go across, and so this 10 over here is my opposite side, O. Then after that, I'm going to just look at the final side, which is the one that is left over. So this side over here with my X is my adjacent side. Once we've done that, we identify our trig ratio. So I have my 3 trig ratios, and we use this acronym Sohcahtoa to remember it. If you remember, the S, C, and T represent sine, cos, and tan. So S for sine, C for cos, T for tan. And the letters afterwards tell you which sides we use. So if you have a look here, we have sides O and A, and so we're going to be using the tan trig ratio. So here, let's write that out. So I'm going to write tan, and with my tan, I'm going to put in the angle. So here, I'm going to write in the angle 45 degrees. So when you use your trig ratio, you put in your angle inside that trig ratio. So that's what we're going to do on the left-hand side. And then we're going to write our trig ratio as a fraction. So the first thing we're going to write is, if we have a look, we have OA, so O over A. The first one is the one on the top in the numerator. The second one is the one in the bottom in the denominator. So here, 10 over X. Now because X is in the denominator, the bottom part of the fraction, what do I need to do? If you remember from last lesson, I do a nifty little trick where I swap the two. So I have X, I swap the X and the tan, and so I end up getting X is equal to 10 over tan 45 degrees. And so I can put that in my calculator. I'm going to grab out my calculator here. So let me get that up. I'm going to open up my calculator. And we can put into our calculator 10 over tan 45, and I close the bracket. And that gives me 10. So my side length X happens to be 10. And so that's what we've been focusing on the last couple of lessons. We've been looking at using trigonometry to help us find missing sides. So we did the shorter sides in the first, and then we did the denominator in the most recent lesson. Now that's what we've been doing so far. But as I said before, trigonometry is the study of 3 angled shapes. So not only are we going to be looking at the sides, we're also going to be looking at the relationship between the sides and the angles. So let's have a look at this triangle over here. You might be given a triangle where you, instead of having the angles given to you, you have a missing angle. So if you have a look at this triangle over here, on the bottom left, this angle here, I've written a theta. If you remember, theta just is the Greek letter that represents my angles, and here theta is just an unknown angle. I don't know what theta is equal to. I don't know what the size of that angle is, but I have 2 sides in my triangle. So if you have a look, I have the two other sides of my triangle. Let's label this triangle. So first of all, I have the hypotenuse here. I'm not going to be using that one. I have my opposite side here of 10, and I've got my adjacent side here of 10 as well. So if you have a look, this is actually the same triangle as the one up above, as the one that we have just solved, that x was equal to 10. What we actually want to do is be able to figure out, if I get given these sides, is there a way that I can go backwards? Is there a way that I can go backwards to help figure out what that theta is equal to? So if we wrote our usual trig identity for this triangle here, what you would have noticed is you wrote tan theta is equal to opposite over adjacent, so we would have written 10 over 10. And what we want to figure out is there a way that I can get theta by itself? Is there a way I can get theta by itself? And this is where we use a thing called inverse trig. When we're dealing with when we're dealing with these problems, when we're trying to find a missing angle, instead of using our regular trig ratios of sine, cos, and tan, we end up needing to use something called inverse trig. So let me see if I can get this to close. Oh, there we go. We use something called inverse trigonometry. And so that's what we're going to be focusing on in this lesson. So we're going to be using inverse trigonometry to help find a missing angle.